Hello and welcome back. My name is Manny. We're coming to you from the downtown city center, and today's topic is the notion of a statistical study versus statistical experiment. This is part 4 in a multi-part series in statistics. Now, before proceeding, we want to acknowledge the participants involved here. You can see here. We want to talk about an observational study, one in which the experimenters observe and measure but do not interfere. And we're looking at 3 types of studies. Retrospective refers to going back in time and collect the data for analysis. The second case is called cross-sectional study, where the study takes place or the data is measured at one point in time and then evaluated. Then the prospective study is one where the data observations are made at a future period. And here are 3 examples. Now the key word here, the researchers studied 1,029 traffic crashes. This is in the past, the retrospective study. In this case, today these meters will be used to determine proportions. This would be cross-sectional. And finally, the study workers from now until several years into the future. This is prospective. Now, an experiment, in contrast, is one in which the experimenters actually manipulate the subjects in groups. The first example is called the completely randomized experimental design, where a random sample is selected and each subject is assigned a treatment in a random fashion. An example is, of course, where we take a sample of people and for each individual we flip a coin and assign them to one of 2 groups. Heads, the aspirin group; tails, the placebo group. We'll discuss the word placebo in just a few minutes. Now the problem is, with this type of experiment, you can have some confounding factors, such as any differences due to gender or age or whatever, so these may come into play. The remaining one is called a randomized block design, in which the subjects are divided into 2 homogeneous groups. In this example, we have 2 blocks, male and female, and within each group we randomly assign males to one of 2 groups, placebo versus aspirin, and females to placebo versus aspirin. So we now have 2 blocks with blocking out the gender effect. And this will potentially remove the potential source of variability due to gender. Now, placebo is a fake pill or ineffectual treatment, or sometimes called a sugar pill, and it's designed to eliminate the effect of one knowing which pill they're getting. Sometimes a patient given a placebo will have perceived improvement in conditions simply because he or she may believe they received the actual pill. This is called the placebo effect. And it should be noted that upwards of 27% of success rates of prescribed medication may be due to the placebo effect. A blinded experiment is one where the participants are prevented from knowing the type of treatment. They don't know if they're getting the actual pill or the fake pill. And the purpose is to eliminate bias. Now, a double-blinded experiment is one where the experimenters themselves do not know which pill the people have received, and this is, of course, to prevent bias on the part of the experimenters during the experiment. Confounding, that's coming on the screen here, may have unknowingly affected the results of the experiments. For example, if we have an experiment where we don't know the effect of gender or whatever, these may indirectly affect the results of the experiment. As you can see here, pause the video and read the details here. And we're going to look at several sites, StatTrack. These are on the internet, and you'll be encouraged to go into Google or go to these sites and look at the material there. This is the end of presentation 1.4. We ask you to review the material once again. Take notes as required and go to 1.05.